So Banggood has sent me a new piece of test gear at no cost. Thank you much, Banggood. They are really good at supporting me and sending me bits and pieces to review to show you and hopefully help you out too. So stick around and we'll check it out. Should be interesting. So here's the box. So what we've got a box in the box. Have a quick look at this. So we've got a manual and some leads and stuff. We'll take a close look at that in a second. And here we have the meter. Let's get it out. There we go, it's out the box. Let's get into it. I haven't powered this up or anything yet. It's the East Tester ET4401 LCR meter, which I think does 10 kilohertz or something like that. There's different models. 4Y obviously for LCR. It's got a grounding terminal, nice enough control panel. Not sure about the button colour. It's like a turquoise. Don't know whether it's showing up on camera. Light's probably washing out a little bit. Power button. Nice physical power button. I like solid physical buttons like that. And it looks like there's a USB port which is covered up, just like it's an option. Maybe not this one. That's what's in the back. IST32 handler, whatever that is. USB port, power, main switching here, so make sure it's not voltage, 220 volts. Well, as close as I'm going to get. I'm 240 here, but yeah, it's close enough. So that's all ready to go. Alright, so look in the box. Bag of cables, so here's a couple of spare fuses and some 4-wire test leads. So yeah, definitely 4-wire going to them. Joining up on here. I've got some of these little leads myself and they actually look alright, they're quite nice. This kind of style, these quite old clips. I think they're gold plated, I'm not sure. You never quite know, might be brass. It's nice BNCs, look like decent quality. Nice strain relief. And then of course I've got a power lead. Has a correct one for my country, but unfortunately not up to the current local standards. They're currently required to be insulated to the first part of that pin there. I think other countries don't really care about that, maybe it's the Chinese plugs. I think China's got the same plugs. We'll see what it's supposed to be rated for. What does the plug say? 10 amps. What does the wire say? 3 by 0.75 mil. 0.75. That's not 10 amps. Right, so here's the manual. Let's have a look. Contents looks pretty extensive, doesn't it? English as well, not Chinese. A lot of pages, so I don't think I'll show you every page. It might take too long. There you go, these specs. We'll look at this one. So we've got this model here, 4401. So it's 5 digits. LCRZ and XDQ phase and ESR. So the difference is that, say this model does 10 kilohertz, other models do 20 or 100 kilohertz. Obviously selectable. Next page. I haven't read any of this. I've been really busy, so I haven't actually had time to play with this thing at all. So it's going to be an interesting experience playing around and seeing how it works. What the hell, I'll show you all the pages. Halfway now. Interesting graph there. Last page. Nothing exciting there. Okay, we'll get onto it. Let's plug the thing in. Dimensions. Sometimes you need to know that for your bench space. So it's about 300 deep to the face of the front panel. If you go to the protrusions like the jacks, it's probably about 315. If you have a cable plugged in the back, it's going to stick out a bit more than that. Just shove it in. Put the cable in the back. If I bend it round to a reasonable angle, 34 centimeters from the cable to the face, it's the sort of thing you need to know when you're sticking things on benches. A lot of my shelves are 30 centimeters deep, so that means this would actually be sticking out by 4 centimeters if I stuck this on my shelf. But some I have actually purchased in the past is some right angle connectors. It just comes out 90 degrees, so you can plug it in there. It saves you a lot of space. Be really handy. And the width, without tilting bail, it's about 24 centimeters. With a tilting bail, it's about 28, with a little bit of a gap each side. And height, yeah, just over 10 centimeters. So our tilting barrel, so this, it's just like normal, you just pull it outwards and turn it. I'll show you angles I can do. So it's either fully back, 90 degrees, 45 degrees, 180, or upright as well. It's probably a position where you can take it off. So you can take the tilting barrel off too. This is fully vertical, which is good if you need to keep your bench space quite small. We've got the power set up. Let's plug the cables in. So we've got H and L. So H would be probably the red ones for high. Tight. And then L as well. Power this up. See what happens. Okay, we have a display. My lighting's washing out somewhat. In fact, I'm going to take away its virginity. Let's have a close look at this thing. Let's see if I can get better lighting on this display. There we go, that's a bit better, isn't it? Make sure you check out the links down below for this thing. I've got links in my description there. Click on the show more link and show more thing there. It will expand it and show you the links in my description there. And there'll be links to this and to Banggood obviously. You can check out more information about from that listing, and I think there might be a manual there as well, I'm not quite sure. Might be an electronic manual. There may or may not be, I'm just guessing. Sometimes there is. So you can go find more details about this thing and some other pictures, that sort of stuff. Even if you don't buy this particular one from Banggood, if you use my link to go there, I'll get a commission on anything you purchase, which helps me to buy more items for the channel. And also buying stuff from Banggood helps me to get a good reputation of Banggood and helps me to get items such as this. This is a fairly expensive item. This is about 180, I think it was, 180 US, I could be wrong. So it's a bit more expensive, and having the good reputation of Banggood means I can get some slightly more expensive items to review. Let's have a look at display. What are we dealing with here? My lighting, as I said, is quite bright and it's washing the display out a little bit. So what you might do is just try and turn some of these lights down a bit so you can see a little bit easier. Okay, I'll turn one of my lights off and that seems to have done the job. That's good enough. You can actually read the smaller detail on the display. Don't forget I've got several thousand lumen of lighting here. When I'm trying to do recording, I've got a lot of really bright lights, so it tends to wash things out a little bit and makes things disappear. So what you're seeing on camera now is probably more like what's actually real life. It's closer to it anyway. So there's a lot of going on in this display. So we've got obviously a resistance readout, function auto, kilohertz 1 kilohertz, resistance out, I don't know what that means. Speeds slow, range auto, level 1 volt. So it's probably doing 1 kilohertz at 1 volt to test capacitors, biasing, so it's no DC bias, comp, don't know what that is, list off. So it's in LCR mode. I suppose we should probably look at doing calibrations first thing, shouldn't we? So there's a cal button. Do an open. We have an open. Okay. Enter. Okay, that seems to be all it required. It didn't require a short. Interesting. Well, let's chuck a capacitor. I've got some capacitors here which I pulled out of bits of gear, things I've repaired. There's a few random ones. I've got no idea if any of these are any good. Some might be fine, some might not be. No idea. I've got these sitting around in case I need to do things like this. So I've got this big capacitor here, which is out of a TV. I know they're all flat. They've been sitting there for months. So it says 90 microfarad, dissipation 0.29. And this is a 10 microfarad cap. Okay, well let's look at other stuff here. So let's look at how do we use this. Can I do that? No. That one? Q. ESR 0.5 ohms. That's series capacitance, CS. Parallel capacitance. So how do I change the frequency? Frequency button. Let's try that. Right, it just increments up each time you push it. Right, it's 10 kilohertz there. Which is the highest frequency, you can test that. It shows 82 now. 100 hertz, do 93. So let's try some others. So small capacitor, this one. This is 16 volt 1000 microfarad, this one. And we get 965 microfarad and 0.1 ohms. Not looking too bad at all. So let's just try a different frequency. Let's go up to 1 kilohertz again. 128. Dissipation was X. I don't know what X is. Anyway, dissipation 0.32. Let's try another one. I'll recheck these as well with another meter and just see what we get with those. So this is a 220 microfarad 10 volt. It's an old Philips one. So 1.3 dissipation and 138 microfarad. That's looking a bit dodgy. Let's step through the frequencies again. Let's go back down to 100 hertz. 243 microfarad. That's 20% out. Dissipation's come back down to 0.49. So let's go back to ESR. 3.2. That's up there a little bit. It's probably a little bit high. So yes, I'm suspicious. Let's get another meter out and we'll do comparisons with that. Let's see how these compare with another meter which I do trust. Right, so I've got my DER D5000 meter out, which is my go-to meter I suppose. There you go, slightly better. Let's change frequencies and do some direct comparisons as well. So let's just grab the same caps. So right now we've got this one here, it's 242 microfarad, 3.2 ohms at 100 hertz. So let's do exactly the same test on DER. Same capacitor. .141 microfarad, that's similar to what that had at that frequency. So let's change frequencies. So 100 hertz, 244, so very close. And dissipation 0.49, I think I said 0.39, didn't it? And let's do some ESR stuff. So I need to take it off that auto. Series capacitance, dissipation, let's do ESR. 3.2. So that actually is very close to what this said. They do pretty much agree. So let's try another capacitor. This is the 1000 microfarad, 960. This said 965, I think. Remember rightly? Dissipation 0.062 at 100 hertz. Let's just recheck on this one. These have the same settings. 0.66. So again, very close. These are, you know, within a ballpark of each other. This meter here I've had for quite a while now. I've had this for a few years. So calibration wise, who knows? It could be a bit off. If it's ever right, I don't know. You know, so these things you just don't quite know what you got sometimes unless you had them calibrated. Comparisons are basically what I can really do here and see if I look about right. If we look at this one again, so it's 100 Hertz, 0.51 ish, 93 microfarad. So 93, 0.05. So ESR, that's 0.8, and ESR 0.85. Based on how many decimal places this has got as well, unless of course they're just faking it, which is possible, accuracy is looking pretty good. This might be more accurate than the DER. It's possible. I've got anything else wacky in here? I've got some really small ones. What are these? This is a 10 microfarad 50 volt. It's just a shame this one doesn't have the 100 kilohertz. I was hoping to get the 100 kilohertz version, but they sent me the 10 kilohertz version. So 100 hertz, 9.5 microfarad, 2.8 ohms, and dissipation 0.1 or 0.16. Can you guys numbers? I probably won't. So 9.5, 2.6 ohms, and dissipation 0.16 or 0.16. So dissipation matches exactly. Those sorts of things, they seem to work just fine. Alright, so that's nice. Oh, so I've got a couple of random inductors here. I've got 1 microhenry and a 10 microhenry, or thereabouts. I don't know how accurate they are. Let's go back to auto mode. Inductance on this one as well. And we'll do side-by-side comparisons again. Again, this is going to be 100 Hertz. So let's do the 1 microhenry first. 1.1 microhenry. What the options are in here? Does have a ESR as well, even on that one. Interesting. 0.37. Dissipation 500 or so. Okay, well, let's do that on the DER. Same measurement. That's only showing 2 microhenry. The resolution on this isn't as good. ESR 0.3, which matched, didn't it? Phase I didn't notice. Dissipation 200 odd. Was that saying 500 odd? That's probably due to the resolution of this. It's not enough resolution on the DER compared to this. I need a superior test instrument to compare it to. So let's do the same test again with the 10 microhenry. Nothing else changed. So we're getting about 9.1-ish, 104 dissipation. Curve 0.009. Phase of 0.55. ESR 0.59, whatever it is. I probably won't remember those numbers. 10 microhenry shows up. 89 dissipation. Oh, 96 dissipation. I can't believe I'm said now. Yeah, forgotten already. Already gone. Q 0.011. ESR 0.5. Phase 0.6. This is a resolution limitation, obviously. This seems to be working alright. I think I might try and find another instrument I can use to compare it against. I've got something else I might be able to use. Okay, so the other instrument I've got is this thing. Almost all digital electronics. The LC 2B. This is a really good little instrument. I rarely use it though, I have to say, because of the capacitance. I tend to use the other ESR meter I showed you before. Now, fortunately, the guy who designed and made these, unfortunately, he's passed away a few years ago now. You can no longer get these things. So I'm really fortunate to have got one of these. It seems to work quite nicely, dreading the day when it breaks. Yeah, it's a real shame the guy who made these passed away. I don't think his family's continuing that work or publishing anything like, for example. Anyway, so back to the 1 microhenry. Let's remeasure on here again. I can't remember which frequencies it uses. It might have 100 kilohertz, I can't remember. So this is measuring on here, 1.2 microhenry. Okay. I'll stick it on here. I've already zeroed it before I started recording. I don't want to bore you with that. Obviously it's only 2 wire, but it's straight between these 2 terminals, and it's 1.2 it's measuring on there. Let's do the 10. So I think the frequency might be different on there. Actually, it might be 100 kilohertz. And this is a 9.1-ish. Stick on here. 1.5. Yeah, they're close. So I've got my ET4401 LCR meter out. Let's do some comparisons. Now, unfortunately, this won't read these things in this lower frequency for some reason. I don't know. Maybe it's something to do with the filtering or something. So it's the 1 microhenry here at 1 kilohertz, and we'll see what it gets. So 1.2 microhenries on that one. 1 volt, no DC bias, 1 kilohertz. So I should probably do that at 1 kilohertz as well, and let's see what comes up, shall we? Just do an exact comparison. So that's like for like. Change the frequency to 1 kilohertz. 1.2 microhenries. It matches. And that's 371 ohms. That's what I should have looked at as resistance as well. or 0.371 ohms, because this does do resistance as well, obviously, because it's an LCR meter, and 0.3703, yeah. So this agrees. It basically matches. Excellent. So okay, let's do the 10 microhenry. I actually repaired this some time ago. About a year ago I did repairs on this thing and fixed it. Had a faulty flip-flop IC in there, believe it or not. So go and check the video on that. Actually, I did about 3 or 4 part video on that about a year or so ago. So this is measuring 0.594 ohms or 593 milliohms, and inductance at range 9.5. Out of range means it's getting to the top of the range, so it's 9.5, which is kind of right. So we'll do the same in this one. So we get 9, so there's a bit of difference there in the inductance, but 0.597 ohms ish, 596, 595. It's settling. The resistance side of it is an agreement. Inductance is very close. It seems to work alright, doesn't it? So I seem to miss it before, but when you're flicking this button around, it will actually go back to an auto mode up here. I was too busy looking here. So as you go through, you will actually go back to auto mode, so it does auto detection about what you're trying to measure. So ranges, range lock, range auto. Okay, so you can lock the ranges. So if you want to do like a range holding, speed, fast, medium, slow. So if I stick my fingers across it, it does change very slow. It's very, very buffered. If I do fast one, I stick my fingers across, it changes very rapidly. I suppose you want that for smoothing and extra accuracy in noisy environments, that kind of thing. I do have a lot of noise here, so being on a slower speed would be beneficial. But if you need a quick, rapid changing measurement, then you can do that too. It's quite nice. Levels: 1.5 volts, 2, 100 millivolts, and 300 millivolts, 600, back to 1 volt again. Nulling out. Okay, so that's offset or zeroing, whatever. It will now take that measurement as a short, when actually it's not a short. Stick them back together, null that out, and again, there we go. Let's stick this in again. Maybe I should be doing nulls when I was doing those other measurements. So back on that data again. So what else have we got in here? We've got a set button. What's this do? Model number, serial number, version, English, brightness 30%. Ah, if I can change that. Oh, no, it's not right. Enter. How do I get down to that one there? Yeah, there we go. It's, here we go, 100% brightness. That's much better. Oh yeah, it only wraps around. So 30% looks okay to me, but on camera it's obviously a bit dim. If I go to 50%, it looks slightly better on camera. Yeah, that's fine. So even 30% to me is actually not that bad. I think I might leave on 50. Power on, default value, so that saves, so it resets the default settings, like factory settings that power up. And I'm guessing you can also do last setting, so whichever you last used that. So that's also a really handy feature to have. If you're always doing the same kind of measurements which aren't the default kind of range, you can tell it to automatically remember the last one you used, so when you power it up it's on the same settings, which is nice. And beep, yeah, turn it on. Here we go. I like key beeps because it's like reassuring, you know, it's actually seen the button. You know, they don't mash things thinking, no, it's not working, when actually you're just not in the wrong menu or something like that. That happens to me a bit. Trigger source internal, pass tone long, fail tone long, okay. So tones, and back to that menu again. Okay, cool. Local, because it's not got anything plugged in, networking, no USB plugged in, that kind of stuff. Comparisons, so how do I get out of this menu? So comparisons, okay, so you can do binning with it as well, that's nice. Tolerances, I guess it's part of the binning stuff, is it? Don't know. Capacitance, actual dedicated capacitance range. ECA, not familiar with that. I could read the manual, or I could just play with it. It's still on the capacitor on here. So that's that 10, oh it's 100 microfarad, I keep calling it 10. That explains why I was getting such weird readings on it, look at that. So it is 100. Why was I thinking that was 10? Okay, it's fine then. You probably yell at me on the screen, that's not 10. Anyway, so 10 90 microfarad, it's got a minus 1.75 X. So it's interesting, it's got that dedicated button there. Wish I did 100 kilohertz though. Maybe it's a way of hacking it. Min and max, microfarad. Okay, and max. So it holds it, yeah, okay. Turn it up again. Averaging. This doesn't seem to be any long press stuff. DCR, DC resistance. So that'd be like a normal multimeter reading. That's something I can measure. See what the voltage coming out of it is, eh? Just hook up my EUV blog meter here. DC resistance must have a DC voltage. 1.3 volts. There you go, it's pulsing on and off. And DC resistance, schematic capacitance. Hold that. Then take it off? Yeah, okay. Oh, there we go, it's up top there. Couldn't quite see it, my lighting's washing out a little bit. There's a hold symbol flashing up here, just in red. So turn the big off again. And saving, apparently. Although that doesn't seem to do anything. But it's got this, what looks like a plugged up USB port just here. So I'm guessing that there's an option for USB. Maybe one of the other models has got USB, and then you can save it to a USB for the readings. Quite possible. There's my remote gone. There it is. There. So make sure you check comments down below. Have a discussion down there, and just any questions, anything you want me to even look at on it. Maybe I might do a review of it, a revisit of the review, and cover anything I may have missed. Let's take all these off. That's a bit tight, I need these plugs. It's a bit, I don't know, it's like the pins are a bit big on that connector there. They're sticking out slightly more than I should. A couple of these in the same way. It's protruding a little bit too far. It's probably a standard for that. Hold on. Jeez, that's being annoying to me. Let's check it out. Yes, I'm measuring the wrong point. 11mm they're protruding, 11.02. Let's find something else which has got a connector on it. Well, let's measure something else, and that had 11.2. So that's actually smaller than the other thing I plugged into. So maybe these plugs are a little bit tight in that way. I mean, can I measure in there? Maybe. See, it's like 11.1-ish. So these plugs might be the problem. They're a bit too tight. Well, just to be sure, I measured the jacks with the BNC connectors on the front of my Rohde Schwarz CMU200. They're going to be good quality connectors. And those are 11.02 as well. So they're actually the same as these, same size. So it must be these connectors here are a little bit tight. This slightly undersized than those. But, oh well, it's something to watch out for, I suppose. So I thought I'd just check the frequency accuracy. So obviously it's doing like switching as well. So it's got a general output frequency, and then it's also doing some other measurements in between. So it's jumping around a little bit. But this is at a 100 Hz setting, and it's doing about 100 Hz. So that's pretty good. So let's change frequencies again. Let's do 120 Hz. Give it a chance to the gating. I've got quite a slow gate time on here. So yeah, that's pretty close, isn't it? There we go. 200 Hz. Just want to see how accurate it is. Yep, about 200 Hz. 400. Yep, that's pretty much 400 Hz. 800. Yep, 800 Hz. 1 kHz. Very close again. Again, because this is doing multiple measurements. I think it's doing some switching in between measurement cycles. I think it does multiple measurements one after the other or something, each reading cycle or something. Anyway, 2 kHz. I just want to check each one. Yep, that's pretty close. 4. So let's unsettle. Yep, that's what it's giving. Slightly low. 8. Pretty close, but very slightly low. And 10. So, yep, again, very slightly low. So it's only talking 70 Hz. So it's not a huge amount out, but it could be better. But it doesn't really matter that much if it's 70 Hz out, probably not. So what do you reckon we do now? Do we should pull it apart? We've only gone through, I think, bulk of the settings. 2 screws. Let's have a look. Been meaning to do this review for about a week. I've had this thing sitting here for a while. I've been busy with a project which I've done a video on, or partial video of, showing some of the project. Okay, that's a rear bezel. I think I'm going to have to take the tilting barrel off. Alright. Yep, that to come off. There's the casing, and there's the inside. So I do kind of wonder why they make these things so physically big when there's a lot of empty space in there. You know, they could have sort of moved this up here and had a unit which is half the depth, which would have then fitted on my shelf quite nicely. It's a bit of a shame. Anyway, let's look at the construction, see how things look, and see what we've actually got in here. Alright, so let's just have a cursory glance around. There's some cut out here for extra options. I wonder what those could be. There's also another mounting post just there, so maybe there's extra options for the other models. A couple more there as well. They're just called JP2, JP3. Partial ribbon here, only half the ribbon, well, less than half the ribbon populated. So I'm just grabbing a little detail. Some chip under there. Max 202 is it? Okay, so that's probably an IS232 driver or something, most likely, because that's what it's going to. And you may notice these plugs. This one here, you can see it's got some gunk on it to help hold it down so it doesn't fall out. As have these ones over here. Gunk on there. And on the back of here, there's gunk on this one as well. So they've done stuff to try and stop the plugs falling out from vibration. Same for the screws on there, so they've been gunked as well, so the nuts don't come loose on those terminals. So we've got some nice tension detail there, so the plug there's gunked down as well. There's a little buzzer there. Let's look at the back. The ribbon's interesting, they've got these cables here cut out of it. But it's the same ribbon going to both terminals here. Obviously that one goes straight to the connector. Maybe just spares on the moment, it just seems a bit weird to do that. Transformer, 8 volts. 110 volts, dual tap, so it's obviously because of switching then runs through both windings for high voltages. So 220, that's fine. But there's multiple taps coming out here. All this lot. So the power wiring, there's a nice earth terminal there. Right, it's all insulated. Those are. That is. This isn't. What's going on here? What's the story here? Okay, it's weird why you got a terminal on there. That's a bit strange. But there's one before the fuse. So what happened here? You've got neutral this side, right? And live that side, which then goes down to the bottom tab, which is going through the fuse inside the holder, and comes out the other side to the bit of mains. Just surprising there's a terminal there. It's just a bit odd. Anyway, so we got bolted down to the chassis, shake proof I think. Yeah, there's a shake proof washer on there, and it's all solidly belted. That's perfectly fine. Happy with that. As is the transformer, so we've got this gunk on there too, so it doesn't come loose. Extra cable there, which is just tied up quite nicely, instead of just being left laying around. Get it in shot. I'm not sure I like this pinching of the ribbon, but it's wrapped, I suppose. It's not too bad. But then you've got the mains AC coming in here with these other low voltage ACs and the ribbons. So I'm not quite sure that's a good idea really. Clamping together the AC stuff, it's got high voltage and low voltage AC, and ribbon cables going to digital circuitry. I mean, sure, it's not a risk of shorting out or, you know, clearances, that sort of stuff. It's not going to be electrically dangerous, but it's going to be potentially introducing noise. Because it's all parallel as well, could be inducing noise in these cables. Yeah, it's probably not the best thing. Anyway, so then we've got the power cable goes to the front there, you've got the physical power switch on the front, so that comes back to the back here. What's that switching? That's switching the neutral. That is switching the neutral terminal. This black wire here is the one that goes to the power switch. Not sure I like neutral switching. AC circuitry it's less critical anyway, but really you should just switch the live terminal, not the neutral. Generally, I mean, it comes back, and that's the neutral going through that switch there, which is then going to the transformer windings. So switching the neutral on both the voltage selection switch and the power switch, and the phase is going straight into the transformer. Well, phase, live, what you want to call it, straight in there, and also linking back down to the selector switch, which also comes up here too. So that's obviously for switching for the winding. Switching neutrals I'm not a fan of, but yeah, I don't think there's anything overly wrong with it. It's not ideal, I don't think. I'm probably being too fussy. So are there any markings to say what the voltages are coming out of this? No. So let's have a look at the back of the board. So there's a little bit of residue on the board. It's not been perfectly cleaned. The flux is still a little bit there. It's not perfect. I mean, it's not sticky or anything. It's just like dust, you know. And over here, you may have spotted this already. You may have done. UART, RX, TX, handshake, 5 volt, ground. Serial port. So that's what's going to the front panel. That serial port there. I wonder if there's any way of playing with that. So yeah, that's the U-part comes down to the front panel there. So it's using serial control to the front. Interesting. Okay, well let's look at the power supply stuff. So we've got obviously some bridge rectifiers. Sorry, I got this right. Full bridge rectifiers! Says monobrow person. I won't say who that is because I think everybody already knows. There's some smoothing caps here. What brand caps we got? Sancon, never heard of them. Doesn't mean they're bad, but it doesn't bode well. So we've got probably a buck converter there. Looks like a buck converter from that design. Switching regulator, there's an inductor and a smoothing capacitor afterwards, so it's probably a buck to go down to the 5V row. It's a 5V terminal there. And also got these big smoother caps here. After that, it's bridge rectifier there, which then comes across to these regulators. So it has some LM317s in there, looks like. Both LM317s. It's a 7805. Yep, 7805 regulator. So I'm actually surprised you've got a buck converter over here. Why don't you just do the same for these? Because buck converters are much more efficient. I don't for noise. I mean, linear regulators are much quieter than buck converters. So I can understand from doing that perspective. This is weird. It's got this residue here. Can you see that residue there? Let's get something to point with. It's under here. There, like that. And if you look further back on these, it's on there as well. And along the edge of the board. See this? What is that? Kind of interesting, really. And if I look closer down here, that's curious, isn't it? What is that residue? It's just like in here. What is this? I think these are read relays, I'm not sure. 4 terminal, yeah, read relays. Well, it could be DC-DC converters. No, smart as K. K read relay. So 3 read relays in there and 2 normal relays. But yeah, this residue is curious. What is that? Is that something been spilt in it, or is it some manufacturing residue? I don't know what it is. I've not seen one like that before. It's strange. I was trying to see what this port here is. It looks like a programming port. Yeah, it looks like a programming port just there. By the microcontroller. There's no number on that chip. It's been etched off. Nothing on it. But what I saw on the front here was an ARM. STM32F103. 12 MHz crystal. So I'm curious about whether this can be made to work at a different frequency. You know, because there is the other versions with the higher frequency options. I'm wondering what it takes to actually get those set up. There's another head over here. Unpopulated parts. Got some stuff out of the ribbon cable there. You might be able to see better from the back. Some devices there. Probably auto isolators or something. That's what I think they might be. Can't quite read them. So those terminals connect up. Look nice enough. Soldering looks fine. I haven't seen anything of any major concern. It's just weird that it's got a residue on the place. A lot of empty space. That's what annoys me a bit, I think. You got all this empty space in there. You could have made the instrument much smaller. You could have got this transformer here, shoved it up here, right, and just compressed the whole lot right down and made something much smaller. I mean, the actual front panel dimensions I can understand, because you need a decent user interface to be able to push buttons and stuff like that. This whole weighted space thing, it just annoys me, really. I've only got so much shelf space, and having stuff which is bigger than it needs to be, a bit of a pain. So, anyway, maybe a reason for it, maybe I share the chassis with other stuff and it's a cost-saving thing, but that's quite likely, in fact. I suppose part of it's also for to give the impression there's a lot more in it than there really is. With modern technology these days, you can do so much with a microprocessor. And considering how much is in here, compare that to the ET4401 which I showed before. You know, that's got boards and boards and boards of stuff, and this has been done by a couple of microprocessors. What do I think of this, really? Well, that transformer there, if you look at this, it's been bent down a bit, but it's not really that much of a problem, is it? It's not going to go anywhere. Function-wise, it seems to work fine. Build quality-wise, it seems okay. The chassis is fairly sturdy. We'll get better once I've got the actual outside on there. It's fairly sturdy. It's probably 1mm thick plate, I think. Just that whole residue build-up thing on the inside there, which I'm puzzled by. What is that from? It could just be part of the manufacturing process and it's been cleaned and it's just not got it all off. Or it could be something else going on there. I don't know, maybe someone's vomited on it, who knows. If you look really closely, you can see a lot of these chips have actually had the markings lasered off them. See, lasered off, lasered off. A couple more at the top there. It's interesting to worry about that much. Usually it's fairly easy to reverse engineer things. They're probably just op amps or something. So, did you guys notice one omission from this device? Something that's missing? Apart from my brains. Nowhere did I see it when I was looking at the device. Do you know what it was? What's missing off this thing? We've had a really good look at it, outside and inside. Something is missing. Guesses down in the comments. Maybe I'll put a comment down there saying what it was. Leave you guessing. Go on, put your answers down there now in the comments. What's missing off the unit? What's glaringly obvious and yet not obvious when it's missing? Come on, put it down there. Okay, I'll tell you what it was. I'll keep you out of suspense. Did you see a QC pass through on this device? Now, does that mean that it didn't pass QC? Or did they fire their QC? Or did they decide that they don't need a QC? Or did they decide that everyone thinks their stickers are a load of rubbish anyway? Anyway, so thanks again. Don't forget to check out the links down below. And thank you very much, Banggood, for sending this to me for no cost. Another little piece of test gear which maybe I can squeeze into my shelf. I'm not quite sure where, but maybe I can. So thanks for sticking around. Thanks for watching to the end of the video. That always helps my channel as well. Give us a thumbs up, very important. Give me a thumbs up. And share the video too if you think people might be interested in this particular unit as a, I don't know, it's fairly economical I suppose, fairly economical LCR meter, which looks like it's got pretty good coverage on it as far as accuracy and resolution. I mean the resolution on this is better than my DER 5000, so that is good as long as the resolution is meaningful. You know, if we got, it's no point having 5 digits if it can only read to 1 digit and the rest of it is rubbish. Who knows? I don't know. I honestly can't tell you if that's the case or not, whether actually the 5 digits are truly being used. No idea. But it certainly looks like it's a nice unit. Construction quality feels fairly good. I mean, it's got rubber bumpers on the side. I didn't really cover that before. These are actually rubber. It seems alright. I mean, it's okay. It's okay. It's not the same as like a high-end Agilent or something like that, you know, Keysight or something weird like that. But, you know, it's not completely a different ballpark. This is, you know, a fraction of the cost or something like that. But as you saw in the beginning, it seems to do accurate measurements. That's what you want. But if you are marking one of these things, you probably want the different model. Maybe you may want a different model. So this is a 4401. We say it's 10 kilohertz only. If you get the 4410, that's the 100 kilohertz, and it might be the better one to get. Just gives you a bit more options. That's obviously going to be slightly more expensive. It's a bit of a trade-off. So give us a thumbs up. Don't forget to subscribe if you don't want to subscribe. Click the bell icon. Because if you don't click the bell, you won't get notified about new videos, that sort of stuff. If anyone's got any input into these things, please do share it down below. And if you've seen other reviews, even other people doing reviews on these things, chuck them down below too, and I'll approve those comments and share them around. Everyone needs to be enlightened about what they're buying, and I'm just one of the channels out there which do reviews. Catch you later. See you next time. Bye. Thumbs up. Don't forget to do that.